Dear students, in this class we will try to prove some of the properties of Hilbert transform. So the first property of Hilbert transform is as shown. Property 1, x of t and Hilbert transform of x of t have same energy density. So in order to prove this, let us consider x of t input signal is having Fourier transform x of f, h of t, that is system response, that is having Fourier transform h of f, and output y of t obviously have Fourier transform y of f. So in frequency domain, this LTI block diagram output equation is written like this: y of f is equal to Hilbert transform of x of f, that is equal to multiplication of two signal. Convolution in time domain is multiplication in frequency domain. So what is h of f here? H of f is nothing but Hilbert transform of h of t. So what is h of t? H of t is nothing but 1 by pi t from our previous discussion. Its Fourier transform is minus j signum function. So if we take magnitude of the system function in frequency domain, then modulus of minus j signum function yields 1. So if we substitute that here, then we are going to get Hilbert transform of the signal and the input signal having same energy density. So coming to the property 2, we have to prove here x of t and Hilbert transform signal are mutually orthogonal. So time domain equation we have written here: integral minus infinity to infinity x of t and Hilbert transform of the signal, that is equal to 0. So here again we consider, let x of t having Fourier transform x of f and Hilbert transform of the signal having Fourier transform x cap of minus f here. Then we are going to substitute the equation in the equation that we are going to prove here. So integral minus infinity to infinity x of t x cap of t into dt, that can be written in frequency domain like this: integral minus infinity to infinity x of f x cap of minus f df. So this is nothing but time domain to frequency domain conversion. So what we know here is x cap of f, that is nothing but Hilbert transform of x of f, is given by multiplication in frequency domain, that is h of f x of f. So what is h of f? H of f is nothing but minus j signum function. So substitute that and call it as equation 2 here. So what is x cap of f here in equation that is 1? X cap of minus f is nothing but h of minus f into x of minus f. So what is h of minus f? It is nothing but minus j signum of minus f into x of minus f. So call this as equation 3. So now what is minus j signum function with minus f represent? It represent, since signum function is odd function, signum function can be written like this: minus j into minus of signum function. So minus into minus yields plus, therefore it is minus j signum function here. So here with respect to equation 3, I am going to replace this minus j signum of minus f by j signum function. Therefore equation this 3 reduces to x cap of minus f is equal to j signum function. Call it as equation 4. Now substitute equation 2 and 4 in 1, that is this second equation and this equation 4 in this first equation. On simplifying, that is integral minus infinity to infinity x of f, what is x cap of minus f? It is given by equation 4. Substitute. and you reorder, that is equal to minus infinity to infinity j signum function into modulus of x of f square df. I have here x of f and x of minus f. Therefore, the magnitude we can write like this. Here, signum function represent odd function and x of f represent even function. Therefore, integration of odd function over integration range minus infinity to infinity is always 0. Therefore, we can say that x of t and its Hilbert transform are mutually orthogonal. So, coming to property 3, applying Hilbert transform twice on signal results in signal reversal. So, it is represented by equation Hilbert transform of x of t is equal to minus x of t, or x cap of t is equal to minus x of t. So, we are going to write this simple block diagram in order to prove this property. So, in the first block, we have shown x of t input signal and output is Hilbert transform of the signal x of t. In the second block, Hilbert transform signal is applied and output is nothing but the Hilbert transform of this signal. So, what is h of t? In frequency domain, it is represented by minus j signum function. What is this h of t? System response. It is minus j signum function. So, in time domain, we have represented this block diagram. So, let us consider h of t is having Fourier transform h of f. Therefore, what is h of f? It is nothing but minus j signum function. So, since this is nothing but cascaded arrangement of linear two-port network, therefore, overall Hilbert transform of this cascaded linear two-port network is given by Hilbert transform into Hilbert transform. So, now you substitute what is Hilbert transform of first block diagram and second block diagram, and you simplify. Minus j into minus j is plus j square. Signum function into signum is nothing but here we are going to have signum square function. But what is j square? J square is nothing but minus 1. What is signum function? It is always 1. Signum square function is always 1. So, when we substitute here, we are going to get the signal as minus x of t because of this j square. That proves this property.